gentlemen, dear colleagues, good morning, everybody. I'm very pleased to welcome you today to an event that, due to the pandemic, would probably have taken place in a different form and in a real place. Every year, we are planning an annual meeting with our partners who also use the Phaidra system to exchange information about projects, plans, and innovations, both on the content and on the technical level. This year, everything is a little bit different. And we took the chance to open the event to all interested people. You may have noticed that 2 roundtables have already taken place in the run-up to the event. The first one was on scrutiny and repeatability, the danger of post-truth academia, and the second one on the role of data in accessibility. Both very interesting roundtables have been recorded and are available online for a long time. And today, we will focus on the topic data management in practice. Some colleagues at other institutions who are in charge of Phaidra will report, as well as researchers who manage their data with Phaidra. But first, a few words about Phaidra at the University of Vienna. Our repository has been available to all members of the University of Vienna since 2008, to all researchers and also to students. Phaidra was developed in a cooperation between the Central IT Service at the University Library of Vienna and is designed as a repository for both literature and research data. Before I now give the floor to Raman Ganguly, he is the technical director of Phaidra and will talk about the future of research data management. A few organizational things. We have a Slack channel running on the side, which you can use during the lectures or at the end of the day for questions. But you can also use the chat. The lectures will be recorded and will be available after the event. But now I would like to give Raman Ganguly the floor. I hope, Raman, it's okay for you?
Yes, thank you.
Fine.
I now try to share my screen.
Okay.
So, do you can see my slides? Great. So, good morning also from my side. This is the third day with live presentations, and maybe also just a remark, organization remarks. This session will be recorded. So if a speaker don't want to be recorded, please tell in the beginning, then we stop the recording. Because afterwards we like to present also the presentations on the web. So if somebody wants to review the recordings, the sessions, or also if somebody is not able to come today, that they have the opportunity to look at the presentation. So now to my presentation, the future of research data management. Why are doing this talk? So that's nothing what we have with the actual practice. But I'm thinking a lot in which way research data management will come in the next years, in the next 10 years, because this is something what we also need to know or should know or predict to know in the way of how the strategic way of infrastructure, building the infrastructure should go, and in which way we want to improve our infrastructure. That's not an easy task. It's very hard, and the question is how to predict the future. This is something what we can see, and there's a I don't know who was the first guy who mentioned this, but we observe what can be achieved in a year, but we underestimate what you can achieve in 10. So it's always, we think always in the way that in 1 year we will do everything, and then we didn't reach all our goals, and then we think, oh, nothing changed anyway. But when we look back, we see that a lot of things have changed. And the question is now how we can think 10 years ahead in a way that we are not in this, in the way like some science fiction movies are doing this. So like, for example, Back to the Future. So I'm still waiting for cars that can fly. But others are pretty nice what they have predicted and what they have done. So how we can do it. And it's also a way a little bit look back to the past, what have been done in the past, but also think about that things will speed up during the time. So looking back to the past, or also looking what's are the big driver for today, which came up for in the last years, and now a big hype. So hypes are also very critical. We have to see on the hypes critical, because the same thing is that when it's a hype, then you think this will be the future, and then it goes a boom, and then it goes down. But something will be there also after 10 years, after 20 years. So also from the big hypes, a little bit have been still remained in the actual situation. So looking at now at the hype topics of research data management, what's now. One of the thing is the big driver now, fair data principles. So everybody is talking now about the fair data principles. Fair data principles is the overall thing, or the overall topic in the European Open Science Cloud, but not only when we look at Europe, it's when we also look at the US. They are also now talking about fair data, the fair data principles. This doesn't happen 3 years ago, so this really came from Europe. And also Australia, they also talk now a lot of fair data. And so this is something what's really rises more and more and more. We had yesterday in the roundtable also the topic fair data a little bit. So this was in the sense of accessibility. From there you can see also what the panelists thought about fair data principles. And they all agreed on this. This is just a starting point. So this is now a hype, but it's just a starting point. So there will be changes, and there will be also changes in what comes along a little bit more with this accessibility, openness, and so on and so on. So this is one big thing. The second, it's not directly related to research data management, but it's in a context. And in two ways you can see the context. So I'm talking about now about artificial intelligence, big data, and high performance computing. So the context is one that these are things which get more and more important in the whole society, but it's getting also important in the sense of how research can work with these things. And it's also from the perspective of research very interesting. And all three, it's not easy when it comes to the topic of data management, because the artificial intelligence is more or less a black box. So it's hard to preserve what artificial intelligence do. Big data, it's not easy. You cannot put big data into a repository. That's not easy. And also high performance computing, there's so much changes in the whole infrastructure. So every year a new computer came there, and how to preserve the outcome, how to preserve how they calculate, how they compute the things. So that's also big things. in the way how we can deal with this in the way of research data management. But on the other hand, it also can help research data management when the sense of thinking about how can artificial intelligence help with metadata. So just auto generating metadata. For this, you also need big data to compare it, to feed it into artificial intelligence. And you need the power of HPC computing infrastructure to compute everything. So this is something which will be also part in the future when it comes to research data management. Also, the question is how to preserve and also how these things can help with research data management. And the third big thing is semantic web. So not only the web, but also the semantic links, how to generate really from all the metadata we have, because we have now a lot of data outside. And the question is how to find, how to discover the right data. And their semantic web can really help you. They can create knowledge graphs. So you can go then from one point to another, can see the relation of the different data, can see how they be computed. So where are the provenance of all the things. So also semantic web will be something which get very important for the research data management. I don't know if you know this picture. This picture came from something which is now very old school. This is from a record of a German band, Tokotronic. It was called Digital ist besser. In English, Digital is better. It was released 1995. And also to see a little bit from the past, they predicted in a way that it goes really in a way of digital, because this was the really first type where electronic music came up, and also the experiment with electronic music in combination with classical guitar rock. So in this way, but when you can remember the year 1995, so this was a year where not a lot of people were on the internet. This was a year where digital cameras even was very expensive, and not a lot of people are using that. So there were no smartphones out back then. And so you see this whole topic, digitalization and digital, it's a really old topic. And now we are getting more and more to the possibilities that things which appeared since the 1960s, so ideas, concepts, and so we have now the possibilities in the machines, in the compute power, and also in a way of how people interact with all the stuff, that the digital revolution now really speeds up. So this is something what we can see. More and more people, even people there are, when you predicted 25 years ago, they will never see that a computer will be important tool for their work. They are now moving more and more to this topic. And in this way, in the digitalization, more and more analog data are getting also digital. So there's a big hype also that analog data getting digital. So we are now digital projects of books, of recordings, so music recordings, but also something where you have talks on it, and also video materials. A lot of things are now getting digital. So more and more data, more and more information become digital. you have these three hypes I predicted before. So you have a lot of data, you can compute them, and there's a change also in the way of how we are working. So what does this now mean in the way of creating infrastructure for research data management? How to what are the big things what we have to consider that it's important when it comes to develop infrastructure for our use? One of the things is machine actionable. So the internet, as we know today, is something what it's designed for human actionable. So this is everything done that a human can enter a website, a human can read the content, can look at the content, and can do something with the stuff on the website. So going to social media, that they can invite friends, they can post something, or they can buy something. So the commercial part is also very important. They can do it. But with the entering of the smart world, I call it the smart world, with a smartphone, a smartwatch, and whatever it's going smart in the next years, smart home, smart refrigerator. So there are more and more machines entering the internet, and we have a big problem there, that all the things what people easily can process and easily and can work with them, machines doesn't is that easy for machines. So we have also now a shift, and this we have to think about, that more and more information, especially when it comes to data, we must create infrastructure where machines can enter this infrastructure and can do something with the data we provide. This is also part of the whole fair data principles. This is also something what they told about. It's important that everything is getting machine actionable, that the things are going in this way. And I really want to talk here about machine actionable and not machine readable, because they need to process it, they need to compute it. The next thing what I see it's important when we think of research data management and research data management infrastructure is integration. We cannot build one big application, they do everything for us. That's impossible. And if we are going to something which is so diverse, like research data, and also the way of thinking how they work with the data and how they process the data, like in research, and always finding new ways how to look at data, because this is one big thing for research, to think new ways. And we need to be more integrative also from our part. And this is not easy, because you have on one hand the whole flexibility which is necessary in the sense of research, and we need to have the stable infrastructure, because we want to preserve them in a long term. So this only goes in the way that we have, that our infrastructure can be easily integrated to the infrastructure what researcher will use and will do, and they can easily move the data inside and move it easily outside. So for these, all the things like APIs, so you need you need this interfaces to connect to each other. And this is also very challenging in the way that you have so many different kind of infrastructure you're dealing with. And this is what also brings me to the third thing. What you have to consider is we need more standards, because if we don't have these kind of standards, the integration will not be possible. And in this way, that you need to connect with all the others, and so that you have the standards that the data can flow from one point to another and from and back again. In this way, we need also to get more and more in conversation with the vendors, because vendors at the moment tend to do everything in their own way, because they're thinking when they have they want to sell us their world, their infrastructure, and data can flow in their world easily. But if they want to go to another way, so they want to cross the border from one world of a vendor to another world of another vendor, this is very hard. And this should be changed. And this, we need really more standards, and also in the way of thinking of formats. We need open standards. We need to discuss this. To see it only from the academic world, that the academic world can now put a pressure on the vendors, this will not be possible. But there is also another thing what's happened in parallel, and I think this is also good when academic will go into the same discussion, because when you go now to when you have now the view of Industry 4.0, this is something where also you need to flow the data from different infrastructures. So they have also the same problem to integrate several things, and also to bring the data from one vendor infrastructure to another vendor infrastructure. So this is also a driver for the whole changes of doing more standards and doing and standardization. You see this also, they are becoming more and more consortiums where vendors come in and designing their standards. Even if some vendors, they are also part of the consortium, will not do this, the standards 100%, but it's a way, and it's in the way we are going. So what does this mean for us? This means also focus on standards, what's already out there, and really keep to the standards, because this will make our life more easier. To wrap up the things is now what will be or what should be in the future. So there's not only something what I can predict or what I think I can predict, is also something what I wish it will happen. This is what I already told you in the whole speech. It's very important that data can move through all the infrastructure without barriers. So also the data management infrastructure should be an integrated part of the research infrastructure, that it's very easy for researcher to bring the data they want to preserve in a long time easily to the archiving infrastructure and bring it back out of again when they need it. So process them and archive them should be from the perspective of a user, something they can do it automatically with not a lot of work in behind. This doesn't mean that planning is not necessary anymore. It's more and more important. So the same happens with project management. So more and more project can. We have tools, we have project gets easier in handling it, but planning is very essential. So that's also data. So it will get more and more essential to data management plan. It will be also integrated part in the project, and not only for research, I think so. this is also the second thing. Research data management is an integrated part of research. So this will not the big topic of this, oh, why I need to do a data management plan, why I need to think about my data, why I do this and why I do that. It will be just something what will common, and this is the good practice of how you do research. Also, think about the data, because the data have a big value, and this value should be predicted, should be preserved. And this is the other thing, is that researchers get known by the data. So also the value of the data, this get in the whole society in the next 10 years more important. So the value of the data is there, and more people will notice this. And researcher will not only get noticed by the publication, they also will get noticed by, will get known by the data they are producing. So this is more or less what I wanted to tell you. This is something what I think, and something in the way also our strategic roadmap goes in this way. And I think we have a little bit time. Would be happy to know what do you think about the future.
So thank you, Raman, for your interesting talk. Thank you for your vision. Thank you for the time travel you did in the 90s. So maybe we can also talk with the other with our people here, because we have enough time now. I think we have 8 minutes left. Yeah. You can also put your questions in the chat if you want. Yes, please feel free to ask Raman anything you want. Yes, don't be shy.
We can also
there's a question from Yuri. What about big data in universities?
Yes, I was. This is something what really changed in my opinion over the last year. I thought so 5 years ago that big data will not be an issue at universities, because big data will be something what happen in the big research infrastructure like CERN or something like this. But what we see nowadays is that big data getting also more and more important, because big data is something which really produced also by the society. And also when you think about something like digital humanities, when you're going to more and more digital, doing digitalization, you have a lot of data. They also have to see in a way that to process it and to look in a different way. And big data is not only something which a huge amount of data, it's something which is hard to process in the way, a lot of data which is hard to process. When you think it in this way, then big data will be a topic for the universities as well.
Thank you.
Thomas?
Hello, good morning, everyone. And many thanks to Raman for this really enlightening talk. I would like to follow up by asking you in which way you think these considerations could be brought into university teaching. We often realize that this is something that needs to be a point that needs to be made and got across. But sometimes it's really very hard to reach the targeted audiences. Perhaps you have some thoughts on that.
Yeah, that's a really good question, and I think a lot of this, and I'm struggling in sometimes. So there's one idea which are very public, which are very popular at the moment, that everybody in a school or everybody in this in a when they're doing a lecture, when they're doing a study, they should learn a programming language. I'm not sure if this is really necessary. I think it's very important that that the younger generation also get trained in what's really digital. It's not meaning that you can use Facebook. That's mean you are you know everything about how the digital world works. So this isn't. So we have to train the people to think more in the digital way. But I don't think that the solution is everybody will learn a programming language. I think we will get more specialized also in different ways. So we need on one hand people, they know the subject, and on the other hand, you know, people they know the digital world and how to build digital infrastructure. And I think there will be a third way of group of person we are missing now. This will the group of who can connect both worlds. And I think this will be a better approach than to teach everybody programming language, because programming language is not easy. That's a completely different way of thinking, and not everybody thinks in this kind of in this way. So I think it makes a sense. We need people who bridge both worlds, and this will be important.
Thank you, Raman. Are there any yes, another question? Yuris wrote, younger generation are learning how to rapidly configure already existing systems, often in a very deep way. A flag this and that generation. Programming is hard, but simple programming can be useful. Nice.
Yeah. Yes, that's right. So that what I mean in to also to think a little bit more in a digital way. So I think it's more important to teach in a way of how computer works, and how this get important also in a way that computers and computing getting more integrated in the way. And what's happened if you something put now on the internet, and very accidentally, because you have now the smartwatch. The smartwatch is constantly sending information through the internet to some apps, and so information about yourself. So you're a part of the digital world in the way that what you're doing is now it's now send it to the internet, and other people can access this data. And this is something, the sensibility of this, I think we have to teach about this.